As of 2026, SpaceX has launched the Falcon 9 rocket over 650 times. They are tossing metal into orbit almost every single day. To get to space, you have to fight gravity, right? And gravity is relentless. It demands a toll, and that toll is paid entirely in fuel. This is where things get weird. Let's imagine you went to take a road trip from New York to Los Angeles, but your car is incredibly heavy, so you need a massive tank of gas. But here's the problem. That gas has weight too. So to carry the heavy gas, you need more gas, which means you need a bigger tank, which requires even more gas to move. By the time you turn the key in the ignition, your car is the size of a skyscraper, and your actual luggage, the stuff you actually care about, is the size of a shoebox. In astrophysics, we call this the Tsiolkovsky rocket equation, or more fittingly, the tyranny of the rocket equation. This equation calculates exactly how much fuel you need to punch through the atmosphere, and the math is brutal. For a rocket like the Falcon 9, about 96% of the mass sitting on the launch pad is just the rocket and its highly explosive fuel. The actual payload, the satellites, the supplies, the astronauts, makes up a tiny 4% of the vehicle. We call this the payload fraction. If physics dictates that you only get to keep a measly 4% of your mass as useful cargo, how did SpaceX completely take over the space industry? How did they drop the cost of launching a kilogram into orbit from the space shuttle era's $54,000 down to less than $3,000 on a Falcon 9? To understand why, we need to look at how we used to treat rockets. Historically, because that 4% payload fraction was so tiny, engineers squeezed every ounce of performance out of their rockets. And when the rocket finally got to space, they just threw it away. They let it crash into the ocean. Imagine driving your skyscraper-sized car to Los Angeles, and the moment you arrive, you push it off a cliff. That is why space was so expensive. But SpaceX looked at this and asked a mind-blowing question. What if you just gas it up again? If you want to land a rocket booster back on Earth, you can't use all your fuel going up. You have to save some fuel to slow down and land. But remember the rocket equation. If you save fuel, you are adding dead weight to the vehicle, which eats into your already tiny 4% cargo space. For decades, the aerospace industry thought this was a terrible trade-off. Why sacrifice precious cargo capacity just to save the booster? Because SpaceX realized something incredible. The math of economics could beat the math of payload. A reusable Falcon 9 carries slightly less cargo per trip, but they don't throw it away. In March of 2026, a single Falcon 9 booster flew for a record-breaking 34th time. By sacrificing a little bit of physical efficiency, they created a massive economic efficiency. As of today, Falcon boosters have successfully landed back on Earth over 614 times. They stopped building a new car for every road trip. But here's the really strange part. Falcon 9 was just the warm-up. Enter Starship, a 400-foot tall stainless steel giant. It isn't just partially reusable, it is designed to be entirely reusable. If Falcon 9 brought the cost down to $3,000 a kilo, Starship is mathematically designed to bring it down to between $100 and $500 per kilo. And it doesn't carry a shoebox. It can carry 150,000 kilograms of payload into orbit. That is the equivalent of launching an entire neighborhood moving van into the cosmos over and over again. And this matters because when you can fly a rocket like an airplane, space isn't a restricted zone anymore. We aren't just sending up small weather satellites. We can send massive telescopes. We can send the foundations of human cities to the moon, and eventually, Mars. Every single atom in your body was forged inside the cores of dying stars. We have spent our entire human history looking up at them, trapped at the bottom of Earth's gravity well. But because we finally beat the math, for the first time, we are actually going back.